The next electron flow pattern is one that you should be really familiar with already, and that's the proton transfer. All this is an acid-base reaction that we covered at the start of the semester. Let's take a look at a couple of examples. In this first one, we're going to start with acetone and react that with hydrochloric acid. Okay, so you should really be able to do this already because you know your acid-base reactions, but the base is very similar to the nucleophile in that we use a lone pair. And then in an acid, it's essentially an electrophile where the proton is the electrophilic atom. So what we do is put our pencil down on the lone pair of the base, draw an arrow to the proton in the acid, and then of course hydrogen can only have one bond, so we need to take these two electrons in the bond and move them onto the chlorine as a new lone pair. In the end, we end up with the proton bonded to the oxygen, that's OH+, plus Cl minus after it gets that fourth lone pair. So this proton transfer reaction is effectively the nucleophilic attack and loss of a leaving group where the electrophile is a proton. So it's almost a subclass of the two that we've talked about. But if it's a proton transfer, it's very specific in that your nucleophile, or base in this case, the head of that arrow is landing on a proton as the electrophilic atom. Here's another example where we're given NaNH2, and we know what to do with this. We should break that apart. Na plus and NH2 minus. You don't have to, but it might be helpful to draw the two lone pairs on that nitrogen. That's going to be our nucleophile or base, and then the proton in this alkyne is going to be our acid. So what you want to do is put your pencil down on the lone pair. If you don't have the lone pair drawn in, you can put your pencil down on the negative charge. Draw an arrow to that proton, and then the two electrons in this bond will go onto the carbon as a new lone pair. So we end up with our NH2, a new bond to the hydrogen that it took from the alkyne, plus we have our alkyne portion, the conjugate base, that now has that lone pair and carries a negative charge. And that will just hang out with the sodium cation still floating around in the solution.